Hi friends, welcome to this video. So in this video I am going to discuss question number 41 to question number 45. Right. So this is from KCET 2018. When the vapors of tertiary butyl alcohol are passed through heated copper at 573 Kelvin, the product formed is, right. So this question has been asked in JEE also. JEE, NEET. The same question has been asked in KCET, right? So here you can see that they have given the name tertiary butyl alcohol. Unless you don't know to write the structure of this tertiary butyl alcohol, you can't solve this problem, right? So let me draw. What is this tertiary butyl alcohol? Tertiary butyl alcohol means this one: carbon, CH3, 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 and OH. OH attached to that carbon which is tertiary C, right? One carbon, two carbon, three carbon, tertiary carbon. So this structure we call it as tertiary butyl alcohol. This, in presence of copper around 573 Kelvin, if we heat this copper, as soon as we send this tertiary butyl alcohol in copper like this, we will be having copper pipe which will be heated around 573 Kelvin. So it becomes a red copper hot, and as soon as we send this liquid here, we will get different product this side. What product we will get? We get oxidized product, right? What means here it means this OH will be removed. This OH and one H from this will be removed as water like this, H2O. You got OH and H. So here we will get a double bond. So it is like CH3. So OH from this and H from the next carbon. So it becomes CH2 now here, because H from this and OH from this removed as H2O. Right. So here carbon valence is 4, right? So we will get double bond here. So we will get alkene. But see, in options they have given the name of the alkene. They haven't given any structure also. So unless you don't know IPAC nomenclature, it becomes very difficult for you to solve some organic problems. So you should be thorough with that also. So what is the IPAC name of this molecule? So see, numbering always starts from here. Double bond alkene 1, 2, and 3. We should see a longest carbon chain. So this is the longest carbon chain. At second position we have got methyl. So IPAC name is 2-methyl. 3 carbon means prop. 1 in we can write, or prop in we can write, right? So this is the IPAC name. So 2-methyl propene. So C, or the question number 3 is, answer 3 is will be the answer for the question 41, right? I hope you understood this. Talking about question number 42. What is the increasing order? What is the increasing order of acidic strength among the following? Right. Acidic strength order they have given. So they have given 3 molecules: para-methoxyphenol, para-methylphenol, and para-nitrophenol. And we have to tell order. They have given 4 options: A, B, C, D. We have to tell the order. So unless you don't know the structure of these molecules, you can't solve, right? So what is the structure of first one? Para-methoxyphenol. So phenol, you know. What is phenol? We should have benzene ring. To that OH should be attached. At para position, what should be there? Methoxy. Methoxy means OCH3. This is nothing but para position methoxy group is there. So we call it as para-methoxyphenol. Second option is what? Para-methylphenol. So again para position. This is benzene ring. Here if we add OH, this is ortho, meta, para. Para position what should be there? Methyl, CH3. So the option 3 will be what? Para-nitrophenol. So it is simply like phenol, and para position I will be having NO2 group. And they have asked acidity order. Acidity. Acidity means if I remove this H plus, I will get H plus and O minus. Similarly H plus and O minus, H plus and O minus, right? So the one which stabilizes this negative charge, will be more acidic, because it will easily give what? H plus. So see, this O minus will be stabilized by resonance by nitro group, because it is a very good electron withdrawing group. So if it is option 1, if it is option 2, it is option 3, the third is more acidic. Why third is more acidic? Because it has got NO2 group at para position, which stabilizes this negative charge by electron withdrawing from mesomeric effect, because of which it easily gives this H plus, so it will be more acidic. So compared to these two, 1 and 2, we know that this OCH3 is a very good electron donating group because it has got lone pairs. So here, as soon as it gives H plus, it gets negative charge. Again, it is giving negative charge to the species. So it is highly unstable. So this is not at all acidic. So last option will be 1 and 2 will be in between. So this is the order. Why 2 is in between? Because this is electron donating group, no doubt, by plus I effect only. This is by mesomeric effect plus M effect, right? So order will be what? Always 3 is more acidic, next comes 2, next comes 1. So 3, 2, 1, 3 is more acidic, next comes 2, 2, next comes 1. So option 3 or the C is the correct option for the question 42. Now question number 43, right? Which of the following is more basic than aniline, right? So aniline, we know that aniline means benzene ring, to that NH2 should be attached. We should tell which is more basic, right? Option A, they have given what is A? Diphenylamine. Diphenylamine means what? Amine means NH, diphenyl means here one benzene ring and here one benzene ring. So this is diphenylamine. Third one, triphenylamine. Triphenylamine means 3 benzene ring like this. So this is triphenylamine. Option C is para-nitroaniline. Para-nitroaniline means NH2 will be there. So this is aniline, benzene ring, NH2 is aniline, para position NO2 group. This is para-nitroaniline. Option D is benzylamine. Benzyl means C6H5 benzene ring, CH2 group. This molecule we call it as benzyl. NH2 means amine, benzylamine. To tell the basic nature, we should know a few things. See, why this aniline is basic? Because of lone pairs. So if it lone pairs, if it donates to H plus, we call it as Levy's base, right? So it is basic in nature. But this is less basic. Why? Because these lone pairs are involved in resonance. Because of this resonance, it can't easily donate this lone pairs to H plus, right? So this is less basic. Similarly here, see, here I have lone pairs. This will be involved to this benzene ring also. This will be involved to this benzene ring also, resonance. So this is also less basic. They have asked more basic than aniline. So here see, 3 resonance, here this circle, this benzene ring and this benzene ring. So because of that resonance, this is also less basic. Here NO2 group is a electron withdrawing group. It is the organic best electron withdrawing group which withdraws this electron. So it can't donate the lone pairs to H plus. So this is also less basic. Here what happens, see, here the NH2 group is not involved in resonance because here I have CH2 group, next comes benzene ring, no resonance here. So it can easily donate this lone pairs to H plus. So this will be highly basic. So this is more basic than aniline. Option D is the correct option. Benzylamine is the more basic, right? So this is about question number 43. Unless you know the name and structures, you can't tell this, right? Coming to question number 44, the 2 forms of D-glucopyranose are. So glucose exists in cyclic form, I have told. Cyclic form. This is from the chapter which biomolecules. There you will learn that. So the glucose exists in 2 forms. One is alpha D glucose or alpha D glucopyranose, we tell, right? So its conformation will be like this: OH, OH, H, OH, and here H will be there, CH2, OH. Where all OH is there, above it will be H. OH means H, H means OH, OH means S. So its name is alpha D glucopyranose. What is the name of this one now? This is nothing but the OH just comes here, H. Other configurations remains as it is. See, here also OH, here also H, here also OH, here also H, CH2, OH. Here it will be H, here it will be OH, and here will be H. So all these configurations are same here, and just only at this carbon the configuration changes. Such diastereomers we call it as anomers. Such diastereomers we call it as anomers. Anomers are nothing but the diastereomers, but in glucose or in biomolecules, this is alpha D glucopyranose and this will be beta D glucopyranose. Right, so we call by the specific name for this diastereomer by anomers. So in option you can see both diastereomer option is also there, anomer, but in glucose we specifically call it as anomers. We have, so this is the correct option, not the diastereomer. No doubt anomers are also diastereomers, no doubt, but specifically we call by the name anomers, right? So that clarity you should know. So coming to the last question of this video, that is question number 45. The question is, among the following the branched chain polymer is, right? So this PVC means nothing but the PVC, polyvinyl chloride. It is used for pipe which will be in linear form, linear, no branching will be there. Bakelite is a thermosetting plastic which will be having cross linking. Cross linking doesn't mean it is branching, it will be having cross linking. Branching in difference. So branching we can talk it here. Polythene, I have high density polythene here and here I have low density polythene, right? So polythene means what? CH2 double bond CH2. If I take N molecule at pressure, temperature, catalyst, what happens? This polymer will polymerize and I'll get a long chain like this, right? Along with that, little branching happens here. Little branching happens here and there, because of which I'll get low density polythene. Low density polythene. To remove this branching, we added, along with that pressure, temperature, catalyst, we added one more catalyst, that is Ziegler-Natta catalyst. Ziegler-Natta catalyst. What is Ziegler-Natta catalyst? Titanium tetrachloride, triethyl aluminum. Triethyl aluminum. So this is nothing but the Ziegler-Natta catalyst, because of which it avoided the branching and I got only linear polymer like this. I got only linear polymer. So that lead to high density polythene. So in low density polythene we will be having branches. So answer for the given question is C. Among the following branched chain polymer will be low density polythene. High density polythene is again linear. It is linear. Bakelite is cross linking. PVC, polyvinyl chloride, is linear, but low density polythene will be having branches, as I have shown you, right? So this is the answer for the given question number 45. I hope this video has helped you. If so, please share with your friends so that it will be helpful for them also, and be subscribed to the channel to get such nice videos on chemistry. Thank you.